Okay, so today I want to introduce the notion of a dictionary to you guys. And I want to motivate it with a problem that my class yesterday had no idea how to solve. So let's see if you can do it. Because I was expecting to get two or three answers and I got nothing. Okay. So here's a deliberately vague question. All right, so far you guys have been really insistent that we tell you exactly what you're getting and exactly what you're receiving in terms of a contract. But that's not how problems in the real world sort of arise. So suppose that I wanted you to write a piece of code that returned the character frequency of a string. That is, I wanted you to encode somehow the information that perhaps the string hello world contains one H and one E and three L's, right? So this is the question. I'm not going to give you a contract. So if I asked you to do this, what answer would you return? Right? You have to think about not only how do you compute the answer, but what does the answer look like? So is there any ideas of what? So I'm going to use the term data representation, right? You need to return an answer, but you also have to figure out how to represent the answer. So does anyone have any idea how I could represent a character frequency? Yeah. Okay, that's good. So you're already beating the other class. Okay, so one option is this. We can just have a list of tuples like this. And I can say H goes to 1, E goes to 1, L goes to 3, O goes to 2, and so on. Okay, so good. You've already beat the other class. Yes. Sure. Okay. We could also do this as a list of lists of size 2. But functionally, that's basically equivalent. And actually, tuples in this case would be more appropriate because we don't want to permute the order. The order here does matter. Okay. So maybe one more idea, and then I'll show you the two that I had. Yeah.
A list of 26 elements, and where 0 is like.
Yeah, exactly. Okay, that's called the one-to-one encoding. So we can all just agree that I'm going to give you a 26 length list where the 0th position is the number of A's, the first position is the number of B's, and so on. I have a slide to make it more clear. Okay, good. You guys beat the other class. I have one more representation that you guys didn't pick up on. That's the to-list representation, where I just give a list of characters and their position give you the position of the frequency in the second list. So in the first list, we have H. In the second list, we have 1. So H has 1 character. In the first list, we have L at position 2 and 3 at position 2 in the second list. And then this is the one-to-one encoding that we just talked about. So if we wanted to find the character frequency of K, we can find it here. So which data representation is smaller? Yeah, the to-list representation, right? One-to-one encodings are fast, but they use like a hell of a lot of memory. I know you guys hate matrices, but like this is a big part of computing, and you're going to have to learn about how to represent matrices because you can imagine having a huge matrix with mostly empty information. Right? Imagine you have a 1 million by 1 million size matrix which has 4 4s in it and the rest zeros. Right, so if you want a one-to-one representation, that would be a huge, inefficient representation of that matrix. Okay, so in both of those cases, all we did was sort of come up with a way that I can associate strings with numbers. Right? We sort of didn't define it explicitly, but we came up with a method that we could use to-list to get from a character to a number, or the one-to-one encoding to get from a character to a number, or the list of tuples encoding. But in each case, fundamentally what we have done is provided a function called a hash function that takes a letter and gives us back a number. Okay, so I want to now write a hash function for each of the representations that we have deduced. And again, a hash function in this case is just going to take a letter and return the frequency. Okay, so let me just give this a correct name. So I want to do 3 hash functions. So a hash function, so here's the first. A hash function needs to take a character, string, and the data representation. So in this case, I'm just going to give it this frequency list, and I need to return an integer. Okay. So how can I now do this? I want to give a character, and I want to return the frequency that's associated with it. So if I'm going to use the frequency list here, how do I do that? So suppose I want to find out how many L's I had. Yeah.
You turn length of, and you make an array of like x for x in the list if x equals a character.
Okay, so basically I hear you're saying walk through the list and find the tuple which contains L. That would be the same sort of, well, I don't know what you're using the length for.
You just return the value, not the frequency.
Well, the frequency is stored in a tuple here, right? L in 3.
Then just,
yeah, return the second half. Okay,
tuple and then
so I'm going to walk through the pairs here, and I can do that like this. So for, let me see, we're going to take a character. I already used C. Okay, we're going to take X and Y in this. Okay, so like the list, okay, so if I have a list of tuples like this, 1, 2, 3, 4, you can either say for X in X's, print X, and that's going to print the tuples. But you can also say for XY in X's, and that will also work. Right, so you can pull out the individual elements of the tuple, or you can pull out the whole tuple itself. That's kind of handy. So I'm going to use that. So I'm going to say for x, y in the frequency. Okay, maybe I shouldn't say x. So for a character, fine. Character count in frequency. If the character is C, I return count, and otherwise I'm just going to return 0, right? That seems like a sensible, if the letter was not found in this list, then I guess we can assume that the frequency counted was 0. Okay, so I can take this hash 1, I can give it, I want to look for an E maybe, and I'm going to give it this frequency, 1. L, 3, great. Let's do the next one. What was our other representation? So let's try this 2-list representation. I'm just going to grab it. So paste. Oh, I can't do that. Boo. All right. So 2-list representation. There's the first. Oh, come on, Python. There's the first list. Invalid character in identifier. Really? Maybe it doesn't like my quotes. Okay. This is why I hate working with strings. List 1. H. Okay, so what I need to do is I want to create a list of all of the unique characters in the string hello world, right? And I'm too lazy to type it out, so I'm going to use some Python. I'm going to turn the string hello world into a set. Do you guys know what a set is? So a set is a list minus duplicates, right? So I can have 1, 1, 1, 1, 1, 1, 1. And this is just going to be the set of 1, right? So we're just removing duplicates from the list. Whoops, provided I do this, right? So I have L1, which was equal to the set of hello world. So that should give me the individual unique characters in this list. In that string, and I'm just going to convert L1 to a list. Great. So now I have that without having to type it. So I need now I need to put in the character frequency. So how many L's? 3. How many W's? 1. H's? 1. O's? 2. R's? 1. 1. Spaces? 1. D's? 1. Okay. So I now want to come up with a different hash function, which again takes a character and takes now 2 lists, basically our data representation. List 2 is a list, and I want to return a frequency, which is an integer. So how can I do this one now? so let me copy this. The code's kind of messy. Okay. So I have this list 1 and this list 2, right? And I remember what we agreed on the encoding here, right? The position in the first list tells you where the frequency is in the second list. So if I wanted to find now a hash function which takes maybe L and the two lists L1 and L2 and returns 3, how would I do that? Well, think how, if I asked you, using these representations, how many O's were there, how would you do that? In any way, yeah.
Would you go through L1 and find the character and find its index, and then what the same index is?
Exactly. So how do I find the index of a letter in a list? That's one way of doing it, but why don't we use the built-in? Okay, so the first thing I want to do is I want to find the index of C in L1, which is easy. So L1.index of C. That gives me a position back in the first list, and then I just want to send this position to the thing in the second list, and that's what I want to return. Right, so here I can hash my W. I give it the two lists. Gives me 1. L. Right, gives me 3. I can do the last one really quickly as well. That's the one-to-one encoding. So let's just take this. I'll set that to frick. So here's the last hash function. I'll just do it. So I'm going to take character, which is a string. I'm going to take this frequency list, which is a list, and I want to return a integer. Okay, so I'm going to cheat a little bit. I'm going to do this exactly the same way as I did the other one, except first I'm going to do this. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Because now I can find the index of C, which tells me what position it is in the alphabet, because I cheated a bit, because I typed in the alphabet. What's the better way of doing this, by the way, without just defining the alphabet? We did a whole lecture on this. Yeah.
Get the range of, like, you make a list of.
No list. There's a more direct way of doing this, yeah.
Should you from like lowercase a to lowercase z?
No, I can't put it. You mean like this?
No, with strings though. Like
How?
like ordinals.
Okay, you're getting in the right direction. So I taught you about ordinal. Okay, so one more try. Yeah, so we use the Unicode. So, because remember that the ordinal of A is like at 97. So, okay, first, like, so I can take any character and shift it by its ordinal, shift it by the ordinal of A, and it will tell me what its position is in the alphabet, rather than just doing the other one. But if you can't remember this on your midterm, this is one way you can cheat, right? If you want to find a character position in an alphabet, you can define the alphabet and find. It's a cheat, but whatever. Okay, so let's see if we can hash, if this hashes properly. So I want to find L in this frequency list. 3. I don't need that. 0. Okay, so let me just define the hash function properly, or maybe more properly. So I want to return the frequency list at the ordinal of C minus the ordinal of A. That should be identical. Okay, so we've solved the problem in 3 different ways, right? So you have to appreciate this, that there were at least 3 different ways that we chose to represent the outcome, the data, like the answer, right? So when you're solving a problem, you're going to have to agree with the person who wants your program what the answer is going to look like. But these data representations that we came up with were fundamentally the same. Right? All that we really cared about was the letters, the numbers, and the hash function that took me from the letters to the numbers. Right? We defined the same hash function 3 times, more or less, right? If we were to write out what letter went to what number. right? The graph of our hash functions would be the same in each case. So, generally speaking, okay, if I want to define a bunch of keys, okay, so here's the language about hash functions or dictionaries, right? So we were taking characters to numbers. More generally, we're going to be taking keys to values, right? So our key was the characters in our first example, and the values were the character frequencies or the numbers. So generally speaking, I can take a map from a set of keys to a set of numbers, provided you give me a hash function. Okay, so now that I taught you about hash functions, forget about them, because we'll never ask you to produce one, not in this course, maybe in subsequent courses. You could take a whole course in hash functions. They're that important. Python has a hash function that's like a perfect hash function, because we didn't really mention this, but in each case, we had to like do a linear search for the character, right? What is this? Oh, sorry, that was just, I thought someone had a little xylophone. It was like, I was thinking the other night that I won't be truly successful until there's a lo-fi version of my lecture online somewhere. I don't know if you guys, okay, so at least a few of you know what I'm talking about. That's when I know I will have made it. Okay, so anyways, Python has this idea implemented already. It has a perfect hash function which works in all cases. So I'm going to show you how it works. Okay, so new data type, right? This is always an exciting day. So I'm going to teach you about something called the dictionary, and I'm always going to name them capital H, which may seem strange. But in every other language, well, there's something that's synonymous with dictionary in computer science. It's more typical to say hash table. Right, a hash table is something that uses a hash function for indexing. So I use capital H because I learned these as hash functions. But in Python, they're called dictionaries. But in your mind, you should see these as synonyms. So anyways, here's the syntax for creating a new dictionary. I can show you that its type is dictionary. We can show what it is, and it's curly braces now. Right? So remember sets? Dictionaries can't be ordered. Right? Because the keys can be anything. And the keys can be things that don't necessarily have ordering. So here's the interesting thing about a dictionary. I can now say H of L goes to 3. H of E goes to 1. H of verbic is minus float inf. H of 10 is 10, right? So there's a dictionary. It works like a list, except I'm indexing anything that I really want to. Now, you can't index anything, so I don't know. Let's see if we can index a list. Can we index a list? I don't think so. No. So if you try to index something that is unindexable, it's going to return this unhashable error. Which is why I wanted to teach you about hash functions, so this error would make sense, right? You can't hash this. What you can hash is tuples. Okay? And this has to do with the fact that tuples are immutable, right? Or at least you can't make them any longer, right? They're immutable in the sense that like they're a fixed length. You can also hash strings, obviously. So here's how a dictionary looks like when it's stored in memory, or here's what it looks like when it's printed by Python. You can also create other dictionaries quickly by doing this. You can say 1 goes to 2, and 3, goes to Apple. Right, so there's some dictionaries. I'm going to walk through all of the built-ins on dictionaries, but really quickly I want to say that one typical way of walking through a dictionary is to look, so which ones are the keys in this list up here? Yeah.
The values on the left of the column.
Left of the colon, so L, E, verbic, 10, 1, 2, 3 are the keys in this situation. So, turns out a dictionary is a type of iterable, which means that you can walk through it with a for loop. So see if I print this key here. you're going to get all the keys. LE, verbic 10, 1, 2, 3. I can also do this to print out all the values. Or I can also collect all the values into a set, or into a list, using set comprehension. Oops. All right, so a bunch of options here. But anyways, that's just a very quick overview because I'm going to show you these structures a lot more closely. Okay, so for example, here's how we would encode our character frequency using a dictionary. Right? So we have constants like characters and numbers, we have tuples, we have lists, we have strings, and now we have dictionaries. And dictionaries are probably the most important data structure in computer science. I can make that argument at least. In your job interviews, you're going to be using dictionaries over and over and over again. They're just so incredibly useful for defining things. So try to get a good feel for them. So now when we're talking about problems, we have an option to say, oh, well, will you take a dictionary as a return type? Right? And that's going to be the answer in a lot of cases, to create these dictionaries as a return type. Refactor the character frequency code to use dictionaries and use the following header. Sure. Okay, so let's write the character frequency code. I think we have enough to do that. All right, so just let me... I get to buy a new computer today. I'm happy. There's an Apple event happening in an hour. Tuesday. Code Tuesday. Okay, so let's write a character frequency function. So now that we have dictionaries, I'm going to have to call in a special data type. So from typing, import, and we were using lists, dictionaries. I think that's it for the time being. So let's define this character frequency function. It has to take in a list of characters, like a string. That's it, and it should return a dictionary that's comprised of, what should this dictionary contain? Oh, right, so it's keyed by strings and valued by integers. Okay. So if we call character frequency of C's, of hello, or just hello, this should return a dictionary that looks like the following. So H followed by 1. Okay, technically these should be the single quotes, but I just don't like typing them. E should go to 1, L should go to 2, and O should go to 1. Okay, let's also do the empty one. It should go to the empty dictionary. Okay, so how do we do this? Well, just let me do this because I don't think you've seen enough to know how to do this. So I need to have a new dictionary. So here's the dictionary that I'm ultimately going to return. Right? Return H. Okay, I need to initialize this dictionary. Okay? Because basically what I want is an accumulator for every unique character in the string that's coming in. Right? I'm going to have to count the number of H's and count the number of E's and count the number of L's. Right? So for a character in the set of characters. That makes sense? This is just going to collapse C's into a unique set of characters where it's going to dump duplicates of C's. Okay. Then I'm going to say H indexed at C gets 0. Right? This is how we initialize the accumulator. And then I can walk through the string with the duplicates. And every time I see a character, I'm going to increment the accumulator in the dictionary and then return the dictionary. Character frequency of hello world. There we go. Just let me store this so I can print it out better. So for key in H, let's just print out this tuple, key H of key. There you go. E goes to 1, H goes to 1, O goes to 2. So Python's hash function is so good that when I call this, oops, H of L, that doesn't take, it's not stepping through the whole list to find this. It has a magical way of finding L immediately, right? As if it's like an array index. It can find it straight away. It's a beautiful, magical thing that's constant time complexity to get it out, for those of you who that statement is meaningful. So a dictionary in Python is a data structure that's technically, it's storing tuples. It's storing pairs of key values. Python has a magic hash function to find a key among the tuples fast. Okay, I need to make this very clear. Hash functions will not be tested. You don't even need to know what they are. I'm just telling you so you know sort of behind the scenes what's happening and to make sense of the error messages that you're getting. So I don't want to see questions on Piazza, do I need to know hash functions for the midterm and exam? Because you don't. Dictionaries are not ordered, right? Because the keys can be mixed, so they're not necessarily comparable. And you can mutate dictionaries, right? These things are made for changing. And as I said, hash tables are a candidate for the most important, useful data structure in computer science. So, with the remaining time I have, I'm going to show you each of the built-in commands for dictionaries, right? The built-in commands are ones that you can call by saying dot, the built-in, and calling it as a function. So, items. So if I'm going to define a dictionary here, this dictionary, suppose we're solving some type of problem where we're trying to collect examples of things that are certain colors, right? So this would be a good use case for the dictionary. So H, things that are red, apples, fire trucks, cars, yellow, banana and cars, blue, sky, and cars, right? I did it like this because I made a lab question for you guys. And the lab question is, given a dictionary like this, find all of the items that can be of every color. So in this case, cars can be of every color. So that's a good question. But anyways, there's a dictionary. So I told you what a key was. I told you what a value was. These are the items of the dictionary. The items of the dictionary are the pairings themselves. Now, there's something extra here. You guys have probably never seen something like this. The data type of this of items is not a list. All right, let's go take a look at that. So do I have a dictionary hanging around? Okay, so I have that dictionary from this character frequency example. H.keys is this. Oh, if I could type. Okay. Is the type of H.keys, is this a list? No. All right, so what is the type of H.keys? It's a dictionary keys type. Very strange. Okay, so what this is this is a special iterable. This is a lazy list. So I can still do something like this. For key in H.keys, even though I'm supposed to be doing items. Okay, so for key value in H.values, Jesus, items, print key value. Right, so that's going to work. So you can still, like, this items is not a list, but you can still iterate through it. It's an iterable, right? You can always convert it to a list if you want by doing this, right? But the former thing isn't indexable, where the latter thing is indexable, okay? The reason for this is that dictionaries can get huge, right? It's not a very good idea to load the entire key base direct data structure into memory. It's most smart to walk through the keys one at a time. You don't need all of them at the same time. Well, maybe you do, and then you can get it. But typically, if you just want to process a dictionary, you just need to look at each item one at a time. All right, so that's why these return types are strange. They're not returning lists. They're returning a special type of iterable. So you can still walk through them, but you can't index them. So if you want to index them, you can convert them to a list. So just keep that in mind. Okay, so I can also call the values. I think this should be values and not keys. The values are going to be the... so remember, we have items, keys, and values. So the items are the key-value pairs. The values in this case are going to be the they're going to be the lists of strings, right? So there are the values. But it comes back as this sort of iterable type. What happens if I try to say h of green is leaves? It's fine, actually. This is not going to produce an error. It's because I'm assigning something, right? When you're assigning a variable, when you say x equals 2, Python's not going to say x not found because you're creating it, right? In this case as well, it's not going to say h of green is not found because you're not retrieving h of green. You're creating h of green, right? So that's not going to throw an index error. I did values again. Geez, these slides got messed. Okay, because this slide shouldn't be values, these should be keys. I really screwed this slide up. Okay, so let me just do this. I'll take this, and let's pray that I can...
Sorry.
No problem, no problem. I like the xylophone better. Okay, so we have h.items, which are those. h.values, which are the lists. And then we have h.keys, which are the keys, red, yellow, and blue. Okay? So I can easily say, okay, what do I have at yellow? And that should be banana and cars. But what happens if I say h of green here? So now we're going to get a key error. Right? Key error green. Right? So nothing's there. I can now say this is 1 and now get it back 1. Right? So also note that the data types that are, like the values can also be of mixed types, right? Because here I have I have values which are lists and values which are scalars, like numbers, right? So very useful type of data structure. Okay, so I'll fix that before it goes online. Clear and copy. So dictionaries have the same problem that lists have, and that when you equate them, you're actually equating pointers. So you have copy in order to make real copies of things. So if I take H and I make it this dictionary, and I make a true copy of it into F, I can say then H.clear, which is going to delete the dictionary. Right? So H of blue is going to throw an error. Right? There's no key for blue. Dictionary is empty. But it is the case that F of blue exists. Because I had a copy of that dictionary. So clearing F didn't also clear G. Right? Because I used the copy built in. If I hadn't used the copy built in, both lists would have both dictionaries would have been cleared. More on copy. So I can copy H again, and now I can say blue of H gets appended with Windex, because that's also blue. I had a lot of problems figuring out stuff that was blue, because I refused to put water in, because water is transparent, right? Okay, so H of blue now has Windex appended to it. What is F of blue? Skycar's Windex. Remember these shallow copies that lists have? So when you copy a dictionary, like it's only the outermost structure that gets copied. The list on the inside are still just list pointers. Right? So just play around with this in the labs a bit. Get. Get is useful. Right, so here's my thing again. And I had green, which is fine. But I can also get green. Okay, why do we have this get? This seems to be a little bit worse. Well, notice that I can't access, I don't know, magenta. But I can try and get magenta. Right, so get is safer than indexing. Because if get doesn't find something, it just returns none, right? Rather than throwing an error, which totally stops your program from running, right? So use get, right? You either have to use get or say something like this. X is H of green if green is an index of H, right? I don't know, else float infinity. I don't know, else none, okay? Right, both of these ways are going to insulate you from errors, right? Because you're first checking that the key exists before asking for the value of that key, right? So anyways, use get, it's safer, right, than just indexing into a dictionary. Although it may hide some bugs in your code, right? Because you may be trying to get values for keys that are wrong, and get is just allowing you to call those as none. Set default isn't overly useful. Basically, you can, before you even create your dictionary, or even after, you can give default values for keys. So you see this hash table here doesn't have a green in it, but I've said the default for green is empty. So now when I call h of green, it's going to return empty. But it's not that useful because you still need to like go into your dictionary and define a default value for like everything that you expect to be in the dictionary. So there's something called a default dictionary, which is more robust than this in that it allows you to give a default value for anything you throw at it. But you need to call in a library for that, so I don't recommend you do it. But if you want to check it out, it's in the default dictionary library. Pop and pop item. So we also have this notion of popping that we did from lists. So what are the items of a dictionary? So remember, we had three words to describe dictionaries: keys, values, and items. So what were the items? Yeah, the key value pairings. So popping an item it should pop, as in give you and remove from the dictionary one of the items, one of the key value pairings, where pairings in this case are like displayed by using these colons. So what item will get popped? Why do you say blue? Well, only because I wrote it that way. What's the last one, though? Yeah, but that's the right answer. I'm not sure.
Doesn't the dictionary pop take an argue?
Are dictionaries ordered? No. So can you answer this question? No. That's the answer I'm looking for. So you technically got the answer correct. It's going to give you one of the items. You can be sure of that. But I can't tell you which one because there's no order. Like, you can give an order. I can tell you the order. It's how, like, this is linked in memory. It's just going to walk through. So red is attached to something, and yellow is attached to something, and blue is attached to something, and that forms like a queue, a line, right? And it's just going to go to the end of that line and pop it. But that line has been created sort of randomly. So in this case, it is going to pop blue. But, like, that just happened to be a good guess. Right, so remember, dictionaries aren't ordered, right? Because the keys can be mixed, right? Even in this one, like what types of orderings could we have picked on the keys? We could have ordered them by the length of the key. We could have ordered them by their dictionary ordering. We could have ordered them by a myriad of other hash functions, right? Anyway, so just be careful when popping items for a dictionary. A popping item is very useful because you can write pieces of code like this. You can say, while this dictionary has something in it, let's just print h.popItem, right? So you can process, so let's say process this. Right? The while loop was saying, while there's something in h, right, remove an item in process. And then as soon as you remove the last thing, then you exit. So this is a neat little... While loops are very useful when you have like a list or a dictionary which you want to process every element of, because you can just pop things off, and the while loop is going to handle it for you. So how much time do I have? 10 minutes. Okay, so let's try a few of these questions, and then you can do the rest of them. Which one do you want to do? Okay, I'll show you the options. So we have 10 minutes, I'll do one. So this one is similar to our character frequency question, except I want to return lists of indexes. So basically, given a string, I want you to return to me a dictionary which tells me what a character's position is in that string. So given the string AA, capital A, BB, capital B, capital B, I want a dictionary that tells me that capital A is at the indexes 2 and 3. That's option 1. Option 2, complete the following function. Return the dictionary. Given two dictionaries, basically do dictionary intersection, right? Create me a new dictionary from the keys that are in both of the original dictionaries. So if I give you a dictionary with 1 at 1, which goes to the list 2, and 4, which goes to the list 5, 6, and another dictionary which takes 4 to 8. Why did this go 4 to 9? Oh, it just summed everything. So 6, 11, 19. Okay, so it wants me to do sums like this. That's option 2. Write a function that basically converts a file into a dictionary. Write a function that does a reverse lookup. So I want to find the key that is associated to a value. Or key or keys, actually, are associated with a value. Right, so, because 1 can go to Paul, 19 can go to Verbic, and minus 31 can go to Paul. So a reverse lookup of Paul should return minus 31 and 1. And invert, I want to create a new dictionary with the key values inverted. Which is a little bit harder, right? Because this is not one-to-one. Right? You may have multiple keys going to the same values. You're going to have to figure that one out. Which one do you want to do? This one?
Yes.
With the caveat that I'm going to return an error if it's not possible. So it won't always be possible to invert a dictionary. Can someone tell me why? Yeah.
Because the value you're pointing at is a list maybe?
It's not invertible for the same reasons functions aren't invertible, right? You can only invert a one-to-one function, right? You can't invert a function that's not one-to-one. So you can only invert a one-to-one dictionary. You can't, well, I'll show you what I mean. Okay. Let me go into the terminal here. Let me just exit this. Okay. So I can make a new dictionary, and this dictionary can take 1 to 3, and it can take 2 to 5, and 3 to 7. Okay? There's a dictionary. So obviously if I wanted to reverse this, I could reverse this. I could make a new dictionary that goes from 3 to 1, 5 to 2, and 7 to 3. Right? Okay, let's do it a little bit differently this time. Suppose I have H that takes 1 to 2, 2 to 2, and 3 to 2. What's the inverse of this? Well, this takes 2 to 1, and 2 to 2, and 2 to 3. Oh, I didn't know that would happen. Anyway, so apparently it's just going to take the last thing. It keeps overwriting, right? So you can't invert this because you're not going to be able to. Well, I don't know. I don't know how to represent this, right?
So you can't properly invert it. What if instead of having 1, 2, and 3 as the values for 2, 3 times over, you had just the one value as a list 1, 2, 3?
Okay, so if this went to lists, if originally this was lists, oh no, then I have to hash lists. This is a badly formed question by me. So let's write two functions instead. Let's write a function to determine that a dictionary is one-to-one. And then let's write a function to invert it. Or maybe I should just pick one of the other ones. Okay, well, let's just do this one. I may not be able to explain it that well, but you want to do the reverse lookup instead? The same problem. Because we're going to be finding multiple things. Anyway, so let's just try to do definition. What did I call this? Invert dictionary. So I need to be given a dictionary, and I want to return a dictionary. Let's just assume H is one-to-one, right? And that an inverse exists. And then maybe if I have some time, we can modify it to throw an error when there's not one. Okay, so I just need to create a new dictionary that inverts this. Okay, it's going to change this to F maybe. So here's my H. Return H. Assumes F is one-to-one. H is a new dictionary. So what do I want to do? I want to walk through the key value pairs in f.items. And then I just want to say H at key, oh, no, h at value is key. And I can actually fix this right now. So I can say if key is already in h, then I can sort of return, well, I should throw an error here, right? How do I throw an error? Anyone know how to throw an error? Print not f not invertible. H of value gets key. Okay, let's give this a try. Invert, I need a dictionary. 1 goes to 2, 3 goes to 3. Invert dictionary. This one. Great. Okay, so let's see if I violate my, if 1 goes to 2 and 3 goes to 2, this should return false and print an error. Balls. Why didn't that work? Let's do some debugging. Oh, it's not key in H, it's value in H, because I have to invert everything. Okay, hold on. Okay, that works. Okay, and that should be enough for today. I'm around all tomorrow in my office to help you guys study for your midterm, so I don't want to see all of you panicked on Friday afternoon, right?